All right, so in this tutorial, what we're going to be covering is serial communications. It's also called UART, which stands for Universal Asynchronous Receiver Transmitter. Uh, what this pretty much does is it allows you to, with two wires, connect to any sort of other digital device. And the advantage of this is, in the case with the computer, is that you can actually transmit via this serial communication link from your microcontroller to your computer any sort of random data. So the idea is if your microcontroller is connected to a sensor and the microcontroller is picking up sensor values, you can actually transmit to your computer, actually see it on display, and the computer can do some further processing with the values. So we're going to go ahead and get started. So you want to instantiate the class called serial and PC. And inside PC are going to be two input arguments. So one is the transmit pin, the other one is receive pin. So on the Freedom KL25Z, there's a variety of different that you can select. So PTE1 and PTE0 are the receive and transmit pins for one case. But for what we're going to be doing is we're going to be connecting it to the computer. So we're going to be using the USB pins. So we're going to go ahead and write in here USB transmit and USB receive, so USB RX. All right, so that should be it. And with that, we're going to go ahead and just write something in here to actually print something from the microcontroller to the computer. So we're going to go ahead and just type in serial, or PC, sorry, .printf, and we're going to go ahead and say hello world. I'm going to do a /n, that pretty much means new line. And yeah, that should be it. So the most basic code you can really write for this, and we're going to go ahead and compile. Okay, now before we even get started, you're going to need some sort of program that can actually read the serial data in. So I recommend CoolTerm. It's freeware. You can go ahead and just type in Google CoolTerm, and you should be able to link to this page. Again, it's freeware.dmyers.org. And go ahead and download whatever version you have. If you have a Mac, you have a Windows, or you have a Linux, and go ahead and open that up. All right, so we've already uploaded the code, so let's go ahead and open up CoolTerm and go ahead and watch a few things. So once you open up CoolTerm, just hit New. It'll open up a new communication line. So what you want to do here is actually you want to go ahead and locate your device. So you go ahead and hit Rescan Serial Ports and go ahead and find the USB modem that the microcontroller is connected to. In the case, mine is USB modem 412. If you're a Windows user, this might actually be called COM something. So the baud rate is 9600, which is the default standard, and we're going to go ahead and hit OK. And I'm going to go ahead and connect with this. It says D, but let me go ahead and hit reset on the microcontroller, and it should say hello world. There you go, hello world. And if I hit reset again, it says hello world again, and I can keep pressing this over and over again. So that's the serial communication line. As you can see, it transferred hello world, and you can actually see it. So let's go ahead and have a little more fun with this. So there's actually two ways to do this. So it's not just the microcontroller spitting out data onto your computer. You can actually use the computer to control your microcontroller if you want to, just using this interface. So we're going to go ahead and do that. All right, so we were able to read in hello world from the serial communication port because the microcontroller printed out hello world, and we can pick it up on our computer. So what we're going to do now is we're going to do it the other way around. We're going to type something into the computer, and the microcontroller is going to read it in. And by reading it in, we're going to go ahead and manipulate the LED, the multicolor LED. So let's go ahead and initialize these the multicolor LED functions. So we're going to say digital out. This is going to be red, and the pin name is called LED underscore red, and we're going to say digital out green, and the pin name is called LED underscore green. And then we're going to say digital out blue, which is LED underscore blue is the pin name for that. Okay, and then we're going to go ahead and initialize each of these. So we're going to say red is equal to 1, green is equal to 1, and blue is equal to 1. This pretty much turns everything off. Turns all the LEDs off. Okay, so it's going to print out hello world, and then we're going to go ahead and make a while loop. So what the microcontroller is going to do, it's going to continuously check to see if there's actually something to read, and it's going to interpret whatever we wrote into it, and go ahead and it's going to go ahead and turn things on or off. So I'm going to go ahead and make a while loop. So while true, Now there's this function called pc.readable. What this pretty much does is it outputs a Boolean to check to see if there's actually something to read in. So I'm going to just make this an if statement. So if there's new data to be read, let's go ahead and inside this if statement read the data. So it's we're going to go ahead and assign whatever we read as a character value. So I'm going to say character, this is a command, and it's going to read in a value. So we're going to say pc.getC. So this means get the character. All right, so once we have this command, we're going to go ahead and decipher exactly what this command is and do something about it. So we're going to make a switch case break statement. So the idea of a switch case break statement is it's like a very shortly written if statement, a massive series of if and else if statements. So it's going to check what command is, and we're going to determine what it should be. So we're going to say case. Say case is like if command is this thing. So I'm going to say if capital R, what we're going to do is we're going to go ahead and turn the red LED on. So red is equal to 0. And then we're going to go ahead and break this statement and break out of the switch case break statement. Okay, so the next case is we're going to say if we type in, if it picks up this thing called capital G, we're going to go ahead and turn on the green LED, and we're going to go and break this statement. All right, so the next one is, as always, the blue one. So we're going to say case if the character we typed in is a capital B. We're going to say blue is 0, so we're going to turn on the blue LED, and we're going to hit break. And then let's go ahead and take into account also instances of if we want to turn off these LEDs. So I'm going to say case lowercase r. This is going to make it so that we'll turn off the red LED. So we're going to say red is equal to 1. And then we're going to say case g, lowercase g. This is going to be green is equal to 1. Before I get ahead of myself, we need to make sure this is break right there. Okay, so case lowercase g, we're going to go ahead and turn off the green LED and then break out of the statement once we actually have found that. So case lowercase b is now to turn the blue LED off. We say blue is equal to 1, and then we're going to go ahead and break. And that should be it for this switch case break statement. And what it's going to pretty much do is it's just going to continuously loop around, and it's going to see if there's actually things to read. We're going to read it in, and we're going to determine whether or not we're going to turn something on and off. So let's go ahead and save this and compile it, and throw it into the microcontroller, and we can play around with it. All right, so now that you have the code uploaded, let's go ahead and pull up CoolTerm again. There's going to be one small change you want to make to CoolTerm, so go to Options, and then serial port, go back down to Terminal. What you want to do is you want to set it to line mode, not raw mode. So line mode, what that pretty much does, it allows you to have this little bar here that you can type things into the serial port. Go ahead now and just go ahead and locate your microcontroller and the serial port. I can hit rescan. It's 412 is the one we want. Hit OK, and go ahead and hit connect. Okay, so this is kind of a little finicky. We're going to go ahead and hit clear data right here, just to make it so it's a bit clean. I'm going to hit reset, and it's going to be hello world. Okay, so I can go ahead and type things in, and we can press enter to it, and it's going to go ahead and change colors. So I'm going to go ahead and type in G, hit enter, and it should now have the green LED turned on. If I want to turn it off, I just hit lowercase g and hit enter. That'll turn off the green LED. If I want to turn on the blue one, capital B, turn it off, lowercase b, turn on red, capital R. If I want to turn it off, lowercase r. Okay, so there's also another funny thing you can do with this. You can actually make purple. So if I turn on red and I turn on blue, it'll make purple. Now if I turn on green, it'll actually be white. Nice little thing about this RGB LEDs, they can actually get almost all the colors of the rainbow. So I'm going to go ahead and turn off red to actually make cyan, and I'm going to go ahead and turn off blue, and what I can do is also make orange if I turn on red. So that's it's orangey yellowish, pretty close. So yeah, I can go ahead and have fun with this. Go ahead and turn off all of them, and yeah, just go ahead and play around with it and have fun. But there's also a few other features that you also want to take into account when it comes to serial transmission. So if you go to options here, you can actually see there's this thing called Baud Rate. So you can actually set the Baud Rate, and the Baud Rate is effectively how fast you transfer data across. So there's going to be a little funny thing where if I go ahead and set this to the next Baud Rate, it's not actually going to transmit hello world correctly. So I'm going to go ahead and clear this data and go ahead and hit connect. it's actually going to be just a bunch of gibberish. Let me go ahead and clear this, hit reset, and as you see, it's just a bunch of gibberish. It's not hello world at all. It's just like this thing, just like dot, dot, zero, whatever. So the idea behind this is that you have to ensure that your baud rate is the same baud rate as what is being transmitted as well. So again, like the idea is like if you set it to like the fastest baud rate, it's going to be a bunch of garble as well. So I'm going to hit reset again and look, a bunch of garble, nothing. So with that, you can go ahead and set and change the baud rate options on your microcontroller by using this command called .baud. So I'm going to go ahead and go back to the compiler, and we're going to go ahead and write that code up. So actually, in the very beginning right here, what I want to do is I want to say pc.baud, and whatever value I put in here is going to be the acceptable baud rate. So let's go ahead and see some acceptable baud rates that CoolTerm can tolerate. So I'm going to go ahead and use 14400 is the next one. I'm going to go ahead and type 14400 into that input right here. So 14400. And I'm going to go ahead and compile this. And so now, instead of having the baud rate at 9600, the baud rate is now going to be at 14400. I'm going to go ahead and just put this into my microcontroller. And then let's go ahead and pull out CoolTerm. All right, so we can go ahead and set to 14400, rescan the serial ports, hit OK. And then I'm going to say clear data. I'm going to disconnect it from already. I'm going to reset the microcontroller and go ahead and hit connect. Clear this data, go hit reset again. As you see, it reads hello world just fine. But again, if I set this to 9600 baud and I try reading this again, so I'm going to hit reset on the microcontroller, it's going to be a bunch of gibberish. So yeah, just another thing to keep in mind, you have to, when you're doing this communication protocol link, if you just see a bunch of gibberish, just go ahead and change the baud rate around until you get it right. And make sure that you program the microcontroller so it's at a baud rate that whatever your serial terminal, whatever kind of application you use, can in fact tolerate that baud rate.